All right. So we were right here. We had just finished this problem. Let's move along. So when we talk decomposition of partial fractions, if you think of decomposing, it means it's possible to add fractions like you did for warm-up. You could take something like this, and then get a common denominator and get what you got for your warm-up. Okay, so that's called, I guess, the opposite of decomposition is composition, I guess. But it's possible for us to go backwards, go in the opposite direction. I can give you this, and you can actually tell me what are the two fractions that make up this. Now, a big rule is that the denominator has to factor. So if the denominator doesn't factor, you're not going to be able to break it up the way that we would like. Let's go ahead and take a look at a type of question. So this is the same problem. The process is a little bit, there's like a few steps for us to work through. So let's go ahead and start by saying, now, is the denominator factorable? And we know it is, but we're going to go ahead and do it. So we have 5x minus 4, and then two numbers that multiply to make negative 2 and I have to make negative 1. That would be negative 2 and 1. So x minus 2 and x plus 1. Great. So that is something that we can decompose because it factors, the denominator factors. So now we're going to write it as a fraction of each factor. So I have 5x minus 4 over x minus 2, x plus 1. And I'm going to say that equals a, x minus 2, plus b, x plus 1. So I'm saying, hey, there must be a number that I can put on top of the x minus 2 and another number that it should put on the top of that x plus 1. And those numbers I have to solve for because right now I still don't know what they are. But that should be the form of what a decomposition requires. All right, so we did number 1. We did number 2. Let's move on to number 3 in a different color. This says for us to multiply all the terms by the LCD. Well, for us, the LCD is x minus 2, x plus 1. So I'm going to do it on this side just because I don't have space. So x minus 2, x plus 1. If I multiply that to this first side, I get x of 5x minus 4. And if you multiply it to the second one, the x minus 2 cancels, you get x plus 1. And then the x plus 1 cancels for the b, you get x minus 2. Great. So now it says for us to solve for a and b by substituting the roots of each factor, which is pretty simple. This, I think, is the easiest way to do this. If you can look right here, you guys hopefully notice that if I want to figure out what a is or what b is, I need to cancel one of them out. I have two unknowns here. So the easiest way to do that is to say, okay, in this, what number could I plug in to get rid of this whole term altogether? Well, if I plug in x equals negative 1, this is going to be 0 multiplied by a. I'm only going to have a b if I plug in all the x's as negative 1. So it's pretty simple. You're just looking at the parentheses. What can I plug in there to make it 0? So let's apply that to the entire equation. 5 times negative 1 is negative 5, minus 4 is negative 9. So I just plugged in negative 1 where the x was. This guy completely cancels away. And then if I plug in negative 1 here, negative 1 minus 2 doesn't go to 0. That goes to negative 3, b. And guess what? If I divide both sides by negative 3, I get b equal to 3. So that gives me one of my two terms. I know that this b up here is 3. All right, now if I go over here to this side, what would make that 0 would be 2. So if I plug in 2, I get 9 times 2, which is 10, minus 4. 10 minus 4 is 6. The a part doesn't cancel. I know the b part will cancel because I picked it. The a times, if I plug in 2, I get 3. A times 3. So if I divide both sides by 3, I get a equals 2. So this should be 2. Now, if we go back to our warm-up, or actually to the previous slide, hopefully we see that the 2 was on top of the x minus 2, and the 3 was on top of the x plus 1. And that's what we have. So this is called partial fraction decomposition, and your final answer is going to be this. Like that. Done. All right. All right, this one, I want you to pause the video and try it on your own. Okay, I'm going to go a little bit faster with this one. This equals a over x minus 3 plus b over x plus 1. We're going to multiply by the LCD all the way through, so it's x plus 5 equals a x plus 1 plus b x minus 3. All right, we're going to find our roots. For this one, x equals negative 1. So if I plug that in, over here I get 4 equals b times negative 4, and b must equal negative 1. And if I plug in x equals 3, over there I'm going to get 8 equals a times 4. And divide both sides by 4, I get a equals 2. So now I have my two answers. I'm going to be able to write this as 2 over x minus 3 plus negative 1 over x plus 1. Also, you can switch this up a little bit and make this a minus. Boom. Done. Cool. So that's that problem. Hopefully you did it all by yourself without having to do much. All right, for this one, I want you to get all the way down to clearing your fractions. Just clear the fractions so you don't have any more fractions, and then we'll talk about another way to solve this. Ready? Pause the video. Okay. First thing you should have done is figured out what it factors as. That would be x plus 3, x minus 2. And so 9x plus 2 over x plus 3, x minus 2 equals a over x plus 3 plus b over x minus 2. We clear our fractions by multiplying by the LCD, and this is where I wanted you to stop. A, x minus 2, b, x plus 3. All right, so we could still do what we did before by figuring out what numbers would cancel out the a and what number would cancel out the b and solve for them. You could also put it into, you can create a system. And so I just want to show you that this guy stays the same. We're going to actually multiply this out as ax minus 2a plus bx plus 3b. And then we're going to kind of couple, we want it to model this. We want a number times x plus a number. So 9x plus 2, if I group the ones with x's, it looks like that. And if we group the ones without x's, it looks like that. Now I'm going to say, okay, I want a number times x plus another number. So the number is going to be a plus b, right? If I factor out the x. So 9 equals a plus b, and then plus, and then this is the number that's being added. Because at some point I'm going to know what a and b are. That's what I want to find. Ooh, let's hide this on. So if I say 9 has to be a plus b, and 2 has to be negative 2a plus 3b, I have a system. And I think for right now, I might multiply the top one by 2. So it'd be 18 equals 2a times 2, so plus 2b. If you add that down, that becomes 20 equals 5b. And guess what b is? 4. And then 4 plus what is 9? 4 plus 5 is 9. So a equals 5. But you have to write it up here in the beginning. So 5 over x plus 3 plus 4 over x minus 2. Good work, guys. I'll see you on the next video.